So today we're going to be looking at pH and pOH. They're different ways of measuring how acidic or how basic something is. It should be a pretty relatively simple set of notes. As long as you know how to work a calculator, you should be good to go on this. There's a handful of equations. You'll be given like basically half of them because the other half you should be able to get just from the other thing. You'll see what I mean here in a second. So remember that pH is a measure of how acidic something is. pOH is going to be the same thing, but since instead of power of hydrogen is power of hydroxide, remember bases have hydroxide, so that's measuring how basic it is. So basically, the lower the number for either of those, the higher whatever that thing happens to be. So if my pH is a low number, remember like a pH of 1 or a 2, that's going to be a very strong acid. But if I have a pOH of 1 or 2, that's a strong base. Whereas if I have a higher pH, so like a pH of 13 or 14, I know that's going to be a base because that's above 7, and the opposite is true for the pOH, where if I have 13 or 14, that's going to be an acid. So pOH is just basically the opposite of pH, where if you normally a low number represented an acid and a high represented a base, pOH it all flips, so a low number represents a base, a high number represents an acid. Again, that low and high being where we go around 7, so anything below 7 or anything above 7, with 7 being neutral for both of them. So a few equations we've got that we can use are going to be, the first one is this minus log of H3O plus equals pH. By the way, anytime you see brackets around something, that's indicating that it is the concentration. And so the concentration unit that we're going to be using for pH stuff is going to be molarity. So if you ever need to go through and calculate that, remember molarity, that's the big M, equals moles of solute over liters of solution. So from last unit, you're going to probably need to be drawing in some of that stuff to maybe do something, because it may say you add, so many grams of HCl to so many liters of water, and we need to figure out what the pH is. So to do that, you would convert your grams to moles, figure out the molarity, and then you do minus log of the molarity, and then there's your pH. If you need to go backwards, you could do this 10 to the minus pH, and it is important that there's a negative sign in that exponent there. So if you do, let's say the pH was 5, you would do 10 to the minus 5th, and that would get you your H3O plus or your H plus concentration. And again, that's going to be a molarity, and the vast majority of the time, these numbers are going to be in scientific notation, so it's going to be usually times 10 to the minus something, usually anywhere between minus 1 and minus 14. But it's usually going to be a scientific number with a big negative exponent up there. Then for pOH stuff, it's exactly the same, except instead of having H3O plus and pH, since that's power of hydrogen and that represents hydrogen, since it's power of hydroxide, I'm going to have hydroxide in there. Same thing with the 10 to the minus 1. It's all the same. So for these 4 equations, so first of all, these two, I'm pretty sure I just copied and pasted them down here and then just swapped out the OH's with the H3O plus and then the H with the OH. So on your test, you're given, I know these 2 equations, but you're not given these 2, but it's super simple. You just swap out whatever the, instead of having the acid stuff, you swap it out for the base stuff. Just make sure that you don't mix it. You can't have acid and base in these equations. It's got to be either all acid stuff or all base. Also, these 2 equations are actually the same equation, just rearranged. Based on how logs work, which if you want to know, I'm sure Mr. Wilson will be happy to explain to you, because with him being a math guy, this is definitely up his alley, more so than mine. But based on how logs work, and these are all base 10 logs, so whenever you go to rearrange it, it actually looks like this, because you can't just divide or multiply by a log. It's a whole different kind of math function. Same thing down here. So these equations, not too terribly difficult. You've also got this other equation where pOH plus the pH is going to equal 14. So every single time if you add the pH and pOH together, they're going to equal 14. So if the pH is 5, then, and we want to know the pOH, you could go through, there's another way to do it that's real gross and nasty, but if you know that those two together equal 14, if I know the pH is 5 and I plug 5 in here to solve for pOH, I subtract 5 from each side, pOH comes out to be 9. So very, very simple to use this one. That one is not given to you on the quiz or test, but it also should be really pretty simple to figure out. And then another important thing, for every whole number change in the pH or pOH, the concentration changes by a factor of 10. So that means that anytime the pOH or pH either goes up or down, it's going to be 10 times either more or less of whatever that thing was. So if I go from a pH of 5 to 4, that means that my acid has become 10 times stronger. pH 4 to 3, 10 times stronger again. If I go 3 to 4, it's 10 times weaker. If I were to go from 3 to 1, since that's 2 steps, and each time it's times 10, it's actually going to be 100 times stronger. So just because the pH or pOH goes up by 1, it doesn't mean like, oh, well, it went from 5 to 4, that's kind of the same thing as 4 to 3. No, because it's 100 times each time that it goes up or down a number. Same thing with pOH. It'll increase or decrease the basicness of the solution however many times that way. So just remember, because it's multiplying at each step, it's not like if you go down 3 different levels, it's going to be 30. If you go down 3 different levels, that's 10 times 10 times 10, which is 1,000 times either more or less, depending on what direction you're going and all that stuff. Alright, and then the last one. So for calculating our hydronium and hydroxide concentrations. So the last little equation, and this one it will be given to you on the quiz and the test, is H3O plus concentration times the OH minus concentration is going to equal 1 times 10 to the minus 14th. And so this is always true. So you've got, depending on how you look at it, like 3 to 6 different equations that you'll need to use. So just real quick. So we've got our log ones. So there's the 2 or the 4, depending on, or even a 1, depending on how you look at it. So you have our log ones to get pH and pOH. We have our pOH plus pH equals 14. And we have this concentration one that equals 1 times 10 to the minus 14. So between all of those, if you're given even just a single piece of information, whether it's the hydronium concentration, pOH, whatever it happens to be, using all of those equations, you should be able to figure out, oh, well, I can figure out this thing now, and then now that I have that thing, I can figure out this one, and then I can figure out the next, and so on and so forth. So once you basically, whenever you're given some information, and when you do the concept builder is set up exactly like the quiz will be, where you're going to have a table, and you'll have to fill in information about it. But whenever you're looking at that, it's going to give you probably just one piece of information, and so you're going to have to figure out from that one piece of info what your other things are. So if you're given only the H3O plus, well, you can figure out the OH minus because of this equation here. So you could do your H3O plus divided by 1 times 10 to the minus 14th. Boom, there's your OH negative. You could also solve for your pH by plugging in the H3O plus here. So you do the minus log of that, and then boom, there's your pH. We've also already figured out the OH minus from over here. So you could solve for the pOH that way, or you could, since we just solved for the pH, you can solve for the pOH this way too. And then you could double check with that. So you're just going to use the equation that you need to based on the information you have and what you're trying to find. So you want to find the equation that has what you're looking for, or that has the information that you're given. So, whatever that happens to be, just make sure you're using one of the equations that has it, and you want to use the equation that has the thing that you're looking for as well. So if I want to know OH minus and pOH, I'm going to want to use one of these. If I'm looking for pOH and I have pH, I want to probably use this one. Also, one last thing to note on these four equations here, to figure out which one of these you want to use, you want to use the one that solves for the thing that you're looking for. So if you're looking for pH or pOH, you want to use the first ones, the ones with the log, because trying to get rid of the log on each side, unless you know how logarithms work, which if you've done them in math class before, you've probably forgotten some. You may not have even gotten the logarithms of math class yet. So always, if we're looking for pH, you want to use the log one, because you want to plug everything onto the side that has all the math stuff, so you don't have to do any rearranging, anything like that. If you're looking for the concentration, you want to use 10 to the minus pH or 10 to the minus pOH. So that's the difference in when you use each of those equations. Alright, then lastly, hydronium works the same as H+, so if you remember from the other set of notes, they're basically the same thing. Technically, they're a little different because H+ is different than H3O+, but they act exactly the same mathematically, conceptually, all that stuff. It's not until you get crazy into deeper into chemistry that it makes any difference. But for us, we're going to treat them the same. And then concentrations of 1 times 10 to the 7th are going to result in neutral solutions. And so you would see that if you plugged it in here. So if one of these is 1 times 10 to the 7th, you're actually going to find that the other one equals 1 times 10 to the 7th. That means you have just as much acid as you do base, which means they cancel out, so you have a neutral solution, because it's neither acidic nor basic when they're canceling each other out. Also, if you were to plug it, that 1 times 10 to the 7th, or 1 times 10 to the minus 7th, sorry, into either of these log equations, your pH and your pOH are going to come out to be 7. And we know that a pH of 7 is neutral, so we find that it's neutral that way too.